Okay, so DeepHack.Babel is our flagman product, and we've been developing it quite a while. So it has been recently released. It happened on February the 1st. So it's a good day to speak about it, because now you can download the product from our GitHub account and enjoy it. So the product is written in Python, so the picture is obvious. Okay. So what is DeepHack? First of all, it's an open source library. It's a library for creation dialogue systems, dialogue agents, or you can call it chatbots. And we develop it as a library for creating dialogue agents, but you know, dialogue agents can be very complicated algorithms. So basically, with this library, you can research and perform experiments with any natural language processing algorithms. It not necessarily needs to be a dialogue agent. And who is DeepHack for? So first of all, it is a library for researchers. So you can easily perform your experiments, because you know, usually you need to change some parameters to run some experiments and to log them. And what is important that your code changes very slightly when you perform these experiments, and not with the purpose not to rewrite your code and to log all experiments properly. You need some instruments. So this is what DeepHack can help you with. Also, this library is for programmers who probably don't know how to develop chatbots from the inside. They probably don't know how neural networks work, or don't know very much about machine learning, as probably you do. But they want to build chatbots from ready components, from bricks which they can combine in any way. And in DeepHack, we want to suggest such components, because you see that's not only a platform on which you can perform experiments, but there are also pre-trained algorithms which you can use as ready components for your dialogue agents. And of course, it is a library for industrial researchers, and here I mean that for researchers who are not so math geeks, so researchers, but people who make industrial products, and they also need some ready components from which they can build the agents. So here in DeepHack, we need to define some notions, because you know, that's a very huge library, and we need to create some terms to operate with, and our main term, of course, is an agent. Agent is an algorithm capable of speaking. See, agent is a dialogue model. It's some it's a chatbot, but it consists of skills, and a skill is a single chatbot's talent. You know, there are several skills currently outlined in scientific articles. These skills are goal-oriented, chit-chat, and squad. Squad skill is named after a famous data set by Stanford University, and question answering. So there are only 4 skills, and your agent as a chatbot can have all the skills, or can have one of them or some of them. But the main point is that agent can speak. It's an artificial intelligence, while skills consists of models, and a model is not necessarily a dialogue model. It can be any natural language processing model. For example, a tokenizer, a named entity recognizer, an intent recognizer, or anything you can imagine. And you see, an agent can consist of several skills, and skills consist of models. And you need to commutate between these skills in every particular moment of time. So you receive an utterance from a user, and you need to define which skill will be responsible for an answer. So if you have several skills, how you do decide which skill is responsible? So if a user tells you something like, I want to order a table in a restaurant, you need to decide which skill should answer him. And it can be a goal-oriented skill, it can be chit-chat or something else. So to define which skill is responsible for an answer to a user, you need a commutator. Commutator itself is a model tool. It can be any model, it can be neural network or something else. And this model decides which skill is responsible for an answer. So an agent can be a very complicated system. It can have very complicated architecture, which consists of several neural networks, other algorithms, and a commutator, which commutates among the skills. And to perform these experiments with dialogue agents, you need a platform with which you can do it easily. Because you see, when the architecture is so complicated, it's not enough to do some computation in a Jupyter Notebook or something simple. So let's speak about skills a little bit more, so to understand what they are. As I already said, there are 4 skills, basically. It's goal-oriented, chit-chat, squad, and question answering. What is a goal-oriented bot? Usually it's a personal assistant, and it helps a user to achieve a certain task. For example, to order a table in a restaurant, to book tickets, to get some answer or something else. It can be anything. And usually from the architecture point of view, these chatbots are some modular systems. So usually there are 4 components in these architectures. It's natural language understanding module, natural language generation, dialogue management, and dialogue policies. So it's a modular architecture. Of course, it can be an end-to-end architecture, but usually it's modular. And on the contrary, chit-chat agents usually are end-to-end architectures, and usually it's a single neural network, but again, not necessarily. And chit-chat bots speak with you about anything, so you can discuss with it weather, your health, your emotions, anything you like. There is a squad skill. Squad is a skill of reading comprehension. So a bot reads an article and can answer your questions about this article. So you see, in production, it can be very useful when there is a database and a user asks you about some things in this database, and this database is not structurized. I mean, there are a lot of texts, and a question of a user can be about any of these texts. So your bot should have a reading comprehension skill to answer. Usually, these bots consist of such neural networks as BDAF and other architectures. So there are specific neural architectures to perform this task. And there is a question answering skill. Question answering, there is an asterisk because it's not because this skill can be goal-oriented from the architectural point of view, can be chit-chat, so it's not it doesn't have the same level of it's from the architectural point of view, it can be similar to goal-oriented or chit-chat, and but from the semantic point of view, it's a system that just answers questions. So it is outlined in some scientific articles as a separate skill, but exactly it is not. So, as I already said, there can be modular and end-to-end architectures. And on the picture, on the upper picture, you see a modular architecture, and this one is an end-to-end architecture. And both of them are goal-oriented skills. So you see, the modular architecture is more complicated, not from the algorithmical point of view, because algorithms there can be very simple. Usually some modules are basically rule-based algorithms. But it is complicated from the architecture point of view, because there are many modules, many classes, and you need to program it and to organize these classes so your bot wouldn't be slow. So you need to make some optimization in this architecture. And end-to-end architectures are maybe more complicated from the algorithmical point of view, because you need to teach all this system at once. It can learn at once. But from the programming architecture point of view, it's simpler. And the main difference between modular and end-to-end architectures is that in modular architectures, each component can learn separately. So you can learn natural language understanding model, you can learn dialogue management, dialogue policies, and they can not even know about each other. But in end-to-end architecture, you need to learn everything at once. So the whole overview of this picture is this. This is an architecture of DeepHack.Babel, and this is how far the complexity of chatbot creation can be. So you see, there is an agent which consists of skills. There are 4 types of skills, but in a single nature there can be different types of goal-oriented skills. So they are diverse between a single type too. So there can be different several chit-chat architectures, several goal-oriented architectures, and all this can be a single agent. And you need to switch between these architectures with a commutator. Also, the models themselves, from which skills consist of, can be very different. There can be rule-based components, and usually such components as dialogue policies are rule-based, at least in production. There can be some simple machine learning models. There can be deep learning components. And all it is built with different known NLP libraries. In DeepHack.Babel we have Keras and TensorFlow abstractions now. But also there are used such libraries as NLTK, GenSim, Spacey, almost every NLP library you know. So this is quite a complicated architecture, and to build a single skill, you need to make a pipeline which will teach this skill, and which will which starts from reading the data and ends with a ready-to-use model. So to make this pipeline, you need a chainer component, and a chainer is a component that helps you to stack different features, and these features can be output from different models. So you see, I will explain more about this component now. So now let's do a little bit diving into DeepHack.Babel and take a look how it is organized from the inside, from the programming point of view. So as I already said, you need a pipeline. It starts with a dataset reader component, which reads data and returns it in a specific format. You define this format. Then you need to organize this data for it to be ready to pass to a trainer. And usually you need to train, validate, and test data sets, and you need batches. Then you need index your data. And this is what lookups component is responsible for. you can index whatever you want. Usually people need to index tokens, tags, and chars and classes. And you need a model. A model here is what we call a mother model. It takes as input all other models that take part into a pipeline, and currently it manages their training process. I think in the next release, in beta release, and this is pre-alpha, in beta release we will have a single component that will be responsible for training. But now our mother model is responsible for the training process. And to easily organize this pipeline, you need some instrument. And we decided that JSON config will be okay, because it allows changing any model's parameters, including other models that are inputs of this model. And you don't need to edit the code. So you can change these parameters only in your JSON config, and you don't need to edit some classes constructors to perform your experiment. And also this config allows you to log the experiment, because this JSON saves as it is, and when time passes, you can open this JSON config, and you will see exactly your parameters as they were at the moment when you performed the experiment. So this is how a real config looks like. This is a JSON config of our intent model classifier. So you see there are four main elements. There's dataset reader, dataset, lookups, and model. Model can have parameters for training, and it can have other models as input. So this exact model has embedder and tokenizer as inputs. And these features take part into the training process, which is described by these parameters. And each element must be registered under a name keyword. This is a convention which is very convenient to map your config classes with your real classes in your code. So you can change only these parameters, and when you run your code, it will know which class to change, so you don't need to edit the code. And some of these parameters are already hard-coded as keyword parameters in class constructors. But you can change them here, and what is in your class constructor will be overridden with what you put in your JSON config. So you don't need to put these parameters. You need to put them only if you want to change what is by default. And this config is a skeleton of our DeepHack skill. We have currently we have there only one skill, which is a goal-oriented bot based on a hybrid code network, and these are all models that take part into this skill. So you see, its name is GoBot, and it also has a slot filler component, an intent classifier component, an embedder component, bow encoder, tokenizer, and tracker. And all these components are single models. And intent classifier itself consists of embedder and tokenizer model. And this structure can be very nested. So any model can take as input other models, and it can be very nested structure. So there are 11 separate model classes in this Go bot. So you see, to build a goal-oriented bot, and not even a very clever one, you need to at least 11 models to build this bot. So that's a lot. And this is how a UML diagram of abstract DeepHack classes looks like. So you see, to program all these models, you need some instruments, because we don't want you program them from scratch. So you need some abstractions to help you to program them. And we created such abstractions in DeepHack. Now we have dataset reader and dataset classes. They're not exactly abstract classes, they are base classes. I mean that in abstract class you usually don't have your methods implemented, but in a base class you can have all your methods implemented. But you can use these classes in our pipelines, so you don't have to program them yourself. And also we have a default vocabulary class. So in this basic config, dataset reader, dataset, and vocabs classes are already programmed by us. So you don't need to program them yourself. You can just import from the DeepHack of these classes and use them in your pipeline. Also, there are abstract models. Currently, we have TensorFlow abstract model and Keras abstract model. So, you know, when you program a TensorFlow model class, you program some similar methods. You always program something like save the model, something like load the model, something like feed the model. And all these methods are very similar. And we decided why we don't program them, so you don't have to program these methods by yourself. So if you import TEF model or Keras model from DeepHack, you will have some methods already implemented, and you will just have to program something like feeddict, because features are very diverse. And also there can be different types of models. There can be rule-based models, neural networks, and machine learning. Obviously, these both, TEF and Keras, are neural networks model. But also, we are going to implement something like an abstract scalar model and an abstract rule-based model. And we have already implemented some interfaces that help in doing this. So everything which can be trained inherits from trainable interface. And everything which can be inferred inherits from inferable interface. Here are these interfaces in detail. So you see, this is trainable interface and this is inferable interface. And both of them inherit from serializable interface, because all models can be serialized. which means they can be saved to disk and load from disk. And there are some abstract methods we already implemented, which are train, save, load, and infer. These are abstract methods. So you need to implement them by yourself. But if you create your own class and you create these methods and inherit from trainable and inferable interface, you get the whole DeepHack to work for you. So if you implement your class as it described here, you can use our trainer, which will understand what to do with your model, and you won't have to implement a trainer yourself. So these are TensorFlow model and Keras model classes in detail. You see, these are abstract classes, but not all of these methods are abstract. So as I already said, you have to implement something like forward by yourself, but methods like save and load we have already implemented, so you can use it. And this is how a real class constructor can look like. This is a constructor of hybrid code network bot. So you see, it accepts as input other models, which are slot filler, intent classifier, bow encoder, embedder, tokenizer, tracker, and its network. Also, it has training parameters like use action mask, num epochs, and well patience, and train now. Train now is a bool variable with which we manage the training process. So all models inherited from trainable interface can be trained. So if you need to create a class which needs to be trained, you register it under the name you prefer, inherit it from inferable and trainable interfaces, and just implement the methods that you need to implement. Currently, you have to implement a train method by yourself. But in beta release, I hope you won't have to do it too. And training process is managed by train now attribute. So the JSON config can be nested. So there can be many models. And you need to decide which models you want to train by a single run of this config. So you can manage this by train now attribute. By default, it is false. So you need to write it to assign it true. So this component will be training. And all models that are inherited from inferable interface can be inferred. By inferring, we mean that a model outputs for you what it can do. So if it is a tokenizer, the infer method will return you tokens. If it is a name recognizer, the infer method will return you named entities. If it is a bot, the infer method will return you an utterance. So when you implement all these infer methods, then you can call this method in every model you have, and just to stack all features you received, and to feed this vector to a neural network, for example. There are a few models already implemented in DeepHack, so they can be used as ready models. These models are named entity recognizer based on LSTM and CRF, intent classifier, which is CNN, and speller. There is some statistical model. And there is one skill already implemented in DeepHack, which is a goal-oriented bot. You can read about all these models in detail in our GitHub account. There are articles and links, so if you are interested, you can read all about them. So this was a pre-alpha release, but there are some things we plan for beta release. These things are logging the experiments, and we want to create a universal trainer for, at least for neural networks. We want to create a chainer which will completely change our JSON config, and we already programmed this concept. It looks like this. So this is a JSON config, but in the paradigm of chainer. So you see, when you have a chainer, you don't need to implement such method that encode features. So you don't need to stack features by implementing this code. You just you can just write here inputs and outputs and link them in a proper way, and you will get your features stacked. So there are some minuses in this JSON config. It's not very convenient yet, but it's a good concept. And if we develop it, I think we will be able to do something nicer and something more convenient. Also, we want to implement some adapters. So if you have any neural networks classes and you want them to embed in DeepHack, so you don't have to program in our abstractions. You can just use our adapter classes. And of course, we will implement more models and skills. And you can use them as ready components for your own dialogue agents. So I think this is all. Here is our GitHub account. You can find more information here. So please enjoy and leave your feedback.
Okay, let's thank the speaker. We have time for questions, if you have any. No questions. That means the... Oh, okay. I thought the presentation was so clear. Not entirely.
Actually, my question is about if we compare this particular NLP tool with the other tools like from IBM or from Microsoft and so on, what is the most important point you want to improve compare with another platforms, or just it is another competitor?
That is similar to what we do, and these libraries are LNNLP library, which is made by the Allen Institute, and they have pretty much the same, but there are two main differences. The first one is that we aim to dialogue engines, and they don't. They create a tool suitable for any NLP pipeline. So DeepHack is wider, because to create dialogue agents, you have to implement some dialogue agents abstractions. And the second difference is that Ellen aims to PyTorch. So from the very start, when you read your data in Ellen, you already have PyTorch tensors that output from data reader class. And we don't want to be so linked to a particular neural network framework. So we want to implement TensorFlow abstractions, Keras abstractions, and maybe some other. And also there is place for simple machine learning algorithms like SVM, REF, and so on, and rule-based algorithms. And if you program on Ellen framework, you just can't do that. Well, there are some other frameworks like RAS-NLU. It's from Holland colleagues. And this framework aims to exactly dialogue agents. So see, if you don't do a dialogue agent, but you want to implement some named entity recognizer or tokenizer, you can't do that on RAS-NLU. What about IBM and Microsoft? Well, I don't know similar frameworks. I know there is Tensor to Tensor from Google, which aims to building NLP pipelines on TensorFlow, but again, it exists only for neural networks algorithms and not for dialogue agents at all. So I hope I answered your question.
Okay, thank you. Are there any more questions from the audience? Okay, thank you, Olga, for your talk.